Welcome back, kids, to Flipped Geometry. I'm Mr. Llanos, and we're going to get right into it. Lesson 1-3 Distance and Midpoints. After this lesson, you will be able to find the distance between 2 points. You will also be able to find the midpoint of a segment. When we're talking about the distance between 2 points, it's basically the length of the segment with those points as its endpoints. So we're going to draw a line segment here. We're going to call this one A, B. When we're talking about distance, it's going to be the measure of this length between the two endpoints. Now the distance formula is defined as follows. If P has coordinates x1, y1, and Q has coordinates x2, y2, then the distance between P and Q is defined as the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to practice this by finding the distance between E and F. First, just to get an idea of what it is that we're looking at, we're going to plot these 2 points. So E is at -4, 1, and F is at 3, -1. So we're trying to find the distance between those 2 points. If I were to give you just one tip to make this whole process easier for you, it would be to label your points. So I'm going to look at point E, -4, 1, and label this x1, y1, and then my other point x2, y2. And now we're just going to bring up the distance formula and plug in our points. So EF is going to be equal to the square root of x2 minus x1, which is 3 minus a -4 squared plus -1 minus 1 squared. If we just do the math, this would be 3 minus a -4 is 7 squared plus -1 minus 1 is going to be -2 squared. If we continue, this would be 49. 7 squared is 49. -2 squared is going to be 4. -2 times -2 is 4. 49 plus 4 is 53. So your answer would be the square root of 53, which is approximately 7.28. Now let's find the distance between AM. Again, we're going to start by labeling our points just to make things easier for us. x1, y1, x2, y2. Okay, I'm going to start by writing the distance formula for AM, just actually writing it out. Square root of x2 minus x1 squared plus y2 minus y1 squared. I know I didn't do that in the last problem, but sometimes it's good just to write it out. Let's plug in our numbers. So x2 is going to be 1 minus a -3 squared plus y2, which is going to be 2 minus 4, which is our y1 squared. And if we continue now with the math, 1 minus a -3, which is the same thing as 1 plus 3, it's going to be 4 squared, plus 2 minus 4, which is going to be -2 squared. 4 squared is going to be 16. -2 squared is going to be 4, which gives us the square root of 20, approximately 4.47. Now, for every line segment, there is a midpoint. The midpoint of a segment is the point that is halfway between the endpoints of a segment. Let's go ahead and draw a line segment. We'll call this guy A, and this endpoint B. The midpoint is the point in between A and B. We'll call this guy X. X, of course, is the midpoint of A and B. If X is the midpoint of line segment AB, if X is the midpoint of line segment AB, then the measure of AX is equal to the measure of AB, and we can show that by putting a congruent mark there and there. And we also say that AX, line segment AX, is congruent to line segment XB. Now let's take a look at the midpoint formula. If line segment PQ has coordinates of P at x1, y1, and Q at x2, y2, then the midpoint M of line segment PQ has coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. Basically, we're going to take our two x coordinates at x1 and x2, divide that by 2, and then add our y1 plus y2 and divide by 2 as well. Let's put this into practice and find the coordinates of M, which is the midpoint of line segment GH, where G is at 8, -6, and H is at -14, 12. Again, just like we did before, I'm going to start off by labeling my points. So G, I'm going to call x1, y1, and then x2, y2. Let's go ahead and start by writing our midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Now let's easily plug in our points. X1 is going to be 8 plus a -14 divided by 2, and then we've got -6 plus 12 divided by 2. 8 plus a -14, which is 8 minus 14, it's going to be -6 divided by 2. Then -6 plus 12 is going to be a +6 divided by 2. -6 divided by 2 is -3. 6 divided by 2 is going to be 3. And your coordinates for your midpoint, M, is going to be -3, 3. Let's try another one of these and find the coordinates of the midpoint for line segment XY, which can be found at x, -2, 3, and y, -8, 9. This time we're going to do it a little bit different. We're going to graph the points first just so we can see what it is that we're looking at. So x is at -2, 3. We're going to count by 2. So -2, 3. That'd be here. Call that guy x. And then y is going to be at -8, 9. So -2, 4, 6, 8. 9 would be there. That's our y. Let's draw a line connecting to. That's our line segment. We need to find the midpoint of that line segment xy. Again, let's start by labeling our points. x1, y1, x2, y2, and we need to find the midpoint. So we're going to go ahead and add our x's, x1 plus x2, which is going to be -2 plus a -8 divided by 2, and then add our y's together and divide by 2. So our y's are going to be 3 plus 9 divided by 2. -2 plus a -8, which is -2 minus 8. It's going to be -10 divided by 2. 3 plus 9 is 12 divided by 2. -10 divided by 2 is going to be -5. And 12 divided by 2 is 6. So our midpoint, just call it point M, is going to be -5, 6. If we go back to the previous graph and plot point M at -5, 6, you would see that it would be right -5, there. If you can see, that's pretty close to being the midpoint of that line segment. So far, we've used the midpoint formula to calculate the midpoint when we've been given both endpoints to a line segment. Let's take a look at a different situation. In this example, they want us to find the coordinates of D if E is the midpoint of line segment DF. Let's take a second and try to visualize what it is that they're asking us. So if we had a line segment, let's draw a line segment, call this guy DF, okay? And we have our midpoint, which we'll call E. So they've given us the midpoint and one of the endpoints. And what we need to figure out is the other endpoint. So we're going to go ahead and set up our problem, and let's write D. We don't know what D is. X1, Y1, we don't know those coordinates. E is our midpoint, -6, 4. And F is our other endpoint that we do know, and that is -8, 9. Now I'm going to label these things. Those two are already labeled. Let's label this one X2, Y2, and then our midpoint, this is the X coordinate for our midpoint and the Y coordinate for our midpoint. Now we're going to use the midpoint formula and algebra to find the coordinates for D. So I'm going to set it up X1 plus X2, which we know is -8, divided by 2 equals -6, because that would be our midpoint value for X. Now if we just use algebra and solve for X, we're going to multiply both sides by 2. That leaves us with X1 minus 8 equals -12. Let's go ahead and add 8 on both sides. And the X coordinate for the endpoint equals -4. Now we'll do the same thing with the Y's. Y1 plus 9 divided by 2, because Y2 is going to be 9, equals our midpoint Y value, which is 4. Solve for Y. I'm going to multiply both sides by 2. Y1 plus 9 equals 8. Subtract 9 from both sides. Y1 equals -1. And at the end of the day, our endpoint for D is going to equal -4, -1. If you thought that was fun, let's do it one more time. Okay? Find the coordinates of R if N is the midpoint of RS and S is given. So R, we don't know. Let's go ahead and write R, X1, Y1. We do know N is the midpoint, so 8, -3. And S is our other endpoint that we do know. Okay, I'm going to go ahead and label these. X1 and Y1 are already labeled. We've got our X midpoint value and our Y midpoint value. And this guy over here is going to be our X2, Y2. Plugging this into the midpoint formula, let's go with X1 plus -1, which is our two X values, divided by 2. And that would give us our 8, which would be the X value for the midpoint. Let's go ahead and solve for X1. Multiply by 2 on both sides. We're left with X1 minus 1. Remember, because plus -1, it will be a -1, equals 16. Add 1 on both sides. And our X value for this endpoint, R, is going to be 17. Let's do the same for our Y's now. So Y1 plus Y2, which we know is 5, divided by 2 will give us the Y value of the midpoint, which again we already know is -3. Let's solve for Y. Multiply both sides by 2. Y1 plus 5 equals -6. Subtract 5 from both sides, and we are left with Y1 equals -11. And now we found the coordinates for the endpoint, which would be 17, -11. The last problem asks us, what is the measure of line segment PR if Q is the midpoint of line segment PR? So if you remember from the definition of a midpoint, if Q is the midpoint, that means that PQ is congruent to QR. We could also say that QR is 1/2 of PR. So I'm going to write that out. QR is equal to 1/2 of PR, because this line segment QR is going to be 1/2 of the entire line segment PR. So let's go ahead and plug in what we know. QR we know is 6 minus 3x. And then PR is equal to 14x plus 2. We're going to first need to solve for x. So nothing happens on this side, but let's go ahead and distribute. 1/2 of 14, 1/2 times 14 is going to be 7x, plus 1/2 of 2, 1/2 times 2 is 1. Now let's continue to solve for x. We can subtract 1 from both sides. We're left with 5 minus 3x equals 7x. Add 3x to both sides. 5 equals 10x. Divide by 10 on both sides. We'll just write over here that 1/2 equals x. We need to plug that back into PR, and PR is equal to 14x plus 2. Plug in 1/2 plus 2. 14 times 1/2, or half of 14, is 7 plus 2. And now we are left with PR is equal to 9. I know what you're thinking. You thought we would never get through this lesson, but we have. Now, go ahead and take a few minutes, go over the very few problems that I have for you in the rest of this packet, and then come back and watch the next video.